Hello everyone, this is Meena Kumari from BSc Engineering College. I am going to explain about today 8051 pin diagram. You know that 8051 is a microcontroller and it is an 8-bit microcontroller. It has 40 pins. And 8051 microcontroller have 4 ports and those ports are named as port 0, port 1, port 2 and port 3. Each port size is 8-bit. So the pins are named according to its port name. For example, port 0 pins are named as port 0.02, port 0.7 and port 1 pins are named as port 1.02 or port 1.7. Similarly, port 2 and port 3 pins are named. Port 0 is used for multiplexing both address and data lines. Port 1 doesn't have any alternating function. And again, port 2 lines are used for generating the higher order address lines from A8 to A15, higher order address lines. Port 3 have again alternating functions. We can see that later. Next one, again, you know that 8051 microcontroller have 4 ports. Each port size is 8. So 4 into 8 total 32 lines are used for generating only 4 ports. Remaining lines are 8, and those are 8 are used for connecting. Are used to generate the signals ALE, PSEN, A bar, reset, XTLEN and XTLA to VCC and VSS. VCC and VSS are used for power supply. Let us see one by one. The first pins are XTLA1 and XTLA2. These are connected to the crystal oscillator. You know that microcontroller doesn't have any time. Based on the number of clock pulses only, it processes the work. So generally it operates at the frequency 12 MHz, but in serial communication the operating frequency becomes 11.0592 MHz in order to derive the standard universal baud rates. Next one is the reset. It is used to reset the 8051 microcontroller. What happens when you do reset? The PC becomes 0000H. PC is nothing but program counter and it is used to save the address of the next instruction. When you do reset, the PC becomes clear and becomes the address 000H. This address is called a reset vector address. What happens at this reset vector address? It executes the BIOS program. The BIOS program can also be called as booting program or a monitor program. When you do reset, it makes the system ready and to be used by the end user. Next one is the ALE signal. ALE is nothing but address latch enable. It is used to enable the latching of address. You know that both address and data lines are multiplexed to reduce the number of pins on the 8051. Now let us see how. The number of address bus size in 8051 microcontroller is 16 and data bus size is 8. Total 16 plus 8. Total 20 pins are needed for only generating data and address lines. The size of the microcontroller is 8051 and the number of pins in 8051 is 40. Among 40, 20 pins are used only for generating address and data lines. If you make separate pins for separate signals, the size of the microcontroller may become larger. So, in order to reduce the number of pins, the multiplexing is done. When you do multiplexing, address and data lines, same pins are used for generating address and data lines. So, address bits and data bits both has to be separated. Here the separating of both address and data bits are called as demultiplexing. This is done by a latch with the help of ALE signal. That means when ALE is equal to 1, the bus carries the address bits. When ALE equal to 0, it carries the data bus. The same bus is used for generating the address and also used for carrying the data. When ALE equal to 1, this informs the latch when the bus is carrying the address so that the latch captures only the address, not the data. Here the latch catches only the address bits based upon the value present on ALE signal. Next, coming to A bar, enable external access. It decides whether the first 4 kilobytes of program memory space will be assigned to internal ROM or external ROM. You know that enable external access. You know that there will be external memory, there will be internal memory. The internal memory comes with the IC. External memory means we are connecting externally to the 8051 microcontroller. Now 8051 microcontroller decides whether to access either externally or internally. You know that whatever the program is executed, that will be saved into the program memory. The program memory might be external ROM or internal ROM. The program will be saved into the ROM. Here two types of ROMs are present, external ROM and internal ROM. Okay, now let us see the case. If EA bar equal to 0, that means EA bar, external axis, is a low active signal. When it becomes 0, the external ROM begins from 000H, from starting address. Okay, the external ROM is accessed from starting address. In this case, internal ROM is discarded. Now 8051 microcontroller uses only the external ROM. Here external ROM will only be accessed, not the internal ROM. See the another case. If EA bar equal to 1, the external ROM begins from 1000H, not from the starting. Okay, in this case the internal ROM is used. It occupies the space from 000H to 0FFFH. You know that the internal ROM size is 4 kilobytes. After accessing the 4 kilobytes of memory from internal RAM, it goes to the external RAM. In modern flash ROM versions, the pin also access VPP. Here the EA bar pin can also access VPP in flash ROM versions to write into the flash ROM. You know the purpose of flash. Flash is used to erase the flash ROM have the purpose of we can erase the data and place again another program into it. So by doing some operations. Next one, coming to the program status enable, PSEN. You know that address bus size in 8051 is a 16 bit. So we can access 2 to the power of 16, that is 64 kilobytes of external memory can be connected. Here in the sense external, we have again two types, external ROM and external RAM. ROM is used for saving the program memory and RAM is used for saving the data. Total we can connect 64 kilobytes of external ROM and 64 kilobytes of external RAM, making a total 64 plus 64, 128 kilobytes of memory can be connected, can be accessed. But both have the same address range. Here the external ROM and external RAM both have the same addresses from 000H to FFFH. But this does not lead to any confusion because there are separate control signals for external RAM and external ROM. The control signals are different. Even though we have same address range, here the control signals are generated. For example, the RD bar and read bar signals are the control signals for external RAM. For external RAM, RD bar and read bar. When RD bar pin becomes active, it accesses from the external RAM, not from the external ROM. The next one, PSEN bar is the read signal for external ROM. When this pin becomes active, it reads the signal from external ROM. Don't go to the external RAM. It is called program status enable as it allows reading from ROM, also known as program memory. Here having separate control signals for external RAM and external ROM actually allows us to double the size of external memory to a total of 128 kilobytes from the original 64 kilobytes. Here we are using the different control signals for external RAM and external ROM. Even though both have the same address lines, the microcontroller doesn't confuse. Based on the control signal we are using, it accesses the data from that external RAM or external ROM. Suppose RD bar and write bar signals, if you generate only RD bar and write bar signals are generated, then it goes to directly access from external RAM. If PSEN bar signal is used, it can access the data from external ROM. Coming to the next one, VCC at ground. These are the power supply pins. You know that 8051 works at the voltage 5 volts. And next coming to the port 0. Port 0, these are the 8 pins of the port 0. Port 0.0 to port 0.7. These are the 8 pins of port 0. We can perform a byte operation on the whole port. Byte operation, byte means total how many? 8 bits. So we can perform 8 bit operation on the port 0. We can also access every bit of port individually by performing bit operations like set, clear and complement, etc. That means we can perform bit operations. Suppose among the pins port 0.0 to port 0.7, if you want to set only one pin, for example port 0.0 only to be set, we can select that pin by using bit operations. Set means placing 1, reset means clear means placing 0. The bits are called port 0.0 to 0.7. Additionally, port 0 has an alternating function. It carries the multiplexed address data lines. Here our port size is 8, so we can multiplex only 8 address lines with the 8 data lines. Here the 8 address lines are lower, A0 to A7, the lower 8 bits of address, and the data bits are multiplexed into AD0 to AD7. In any operation, address and data are not issued simultaneously. Both the signals are not generated at a time. After generating the address signals, then only the data signals will be generated in sequence manner. Okay, first address is given, then data is transferred. Using a common bus for both reduces the number of pins. When you do multiplexing, we can reduce the number of pins. First address lines are given. After finding the address, we can transfer the data. So first address bits are generated, next data bits are generated. To identify whether if the bus is carrying address or data, we look at the ALE signal. If ALE equal to 1, the bus carries the address. So same bus is used for generating address and data lines. If ALE equal to 1, the bus carries the address. If ALE equal to 0, the bus carries the data. Coming to the next port, that one is the port 1.0 to 1.7. These are the 8 pins of the port 1. We can perform a byte operation on the whole port. We can also access every bit of the port 1 individually by performing the bit operations like set and clear, complement, etc. Similarly to the port 0. Port 1 has no alternating function. Okay, port 1 doesn't have any alternating function. Coming to port 2.0 to port 2.7. This is the 8 pins of port 2. We can perform byte operation, and also if you want to perform bit operations, we can perform bit operations on the port 2 also. But port 2 have again alternating functions. It carries the higher order address lines. Higher order means A8 to A15. A0 to A7 address lines are generated on the port 0. Here higher order lines A8 to A15 are generated by using port 2. Coming to port 3. Port 3 pins are P3.0 to port 3.0 to port 3.7. We can perform byte operation on the whole port 3. We can also access every bit of port 3 individually. And the various pins of port 3 have a lot of alternating functions. See that one. The first 2 pins, port 3.0, 3.1. These are used to receive and transmit serial data. Okay, this forms the serial port of 8051. Coming to next pin. 3.2, 3.3, INT0, INT1, these are the interrupt signals, hardware interrupts actually. If they occur simultaneously, INT0 is the by default higher priority. Here 2 types of hardware interrupts are there. Those are INT0, INT1. INT1. If both the interrupts are occurred at the same time, then INT0 has the highest priority. Coming to next one, T0 and T1. These are the timer clock inputs, and they provide the external clock inputs to timer 0 and timer 1. Next again, write bar and read bar signals. These are the control signals for external RAM. I told already that write bar and read bar signals are generated on the pins port 3.6 and 3.7. When these signals are generated, they access from external RAM, not from external ROM. 8051 can access 64 kilobytes external RAM from 000H to FFFFH. Okay, let us say total 8051 is a 40 pin IC. In 40 pin IC we have 4 ports. Each port size is 8. So total 32 lines are used for only especially ports. Remaining 8 lines are used for generating different signals. And XT11, XT11 are used to connect to the crystal oscillator. Operating frequency is 12 MHz. Coming to the reset circuit, when you do reset circuit, program counter becomes clear. It clear the program counter, and the address saved is all zeros. That address is called as reset vector address. Address latch enable is used to latch the address, because demultiplexing is done for between address and data lines. Coming to A bar, external access, whether to access external or internally decided by the external access bar pin. Coming to program status enable, we have external memory, external RAM and external ROM. So PSC bar control signal is used to read the signal from external ROM, and VCC ground, these are the power supply pins. And port 0 have Some pins are used to generate multiplexing of address and data lines. Port 1 doesn't have any alternating function. Port 2 are used to generate the higher order address lines, and port 3 have different functions, and it has serial port, hardware interrupts, timers, and control signals for external RAM. Thank you.